Hello, hello. This video is going to be going through molecular Lewis structures, doing the examples we did in class, and then showing you some extra practice. If you're looking for electron rules, that is going to be on a different video that I've already recorded. So this video is going to start and really stay on molecular Lewis structures. I am leaving this up for now. I'm going to have to erase it in just a second because I wanted to point out that this is a molecular Lewis structure, or at least most of one. In a truly completed molecular Lewis structure, you are not allowed to have any of these unpaired electrons left. They all have to be paired up. So obviously for this one, it would pair up with another hydrogen over here and create water. Or it might pair up with a CH3, a methyl group, and create methanol. There are a myriad of things that could attach here. But lone pairs cannot form bonds. Only unpaired electrons, I can't point because I'm not looking at it, only unpaired electrons can actually form bonds. Okay? So these are the electrons that are going to be forming bonds, and it will look like this when it's done. So I'm going to pause this, erase that, and scroll down a little bit, and then we will get started. All right, so there are many different kinds of covalent molecular diagrams. One that we've already looked at is simplified Bohr diagrams. The ammonia and water molecules that were in the last video were examples of simplified Bohr. But simplified Bohr have their drawbacks, aside from the fact that they take quite a while to actually draw out. As molecules get larger and larger and larger, these get more and more complicated, and some of the formulas you guys are going to be drawing for would be enormous if we did simplified Bohr diagrams for them. So instead, we're going to switch, and in this video, we're going to be talking about molecular Lewis structures. In the next video, I'll be talking about structural formulas, and sometime next semester, we'll be dealing with skeletal structures, which can allow us to draw even larger compounds that with even more precision. So as we work down this list, they become more applicable for larger molecules and more confusing for simpler molecules. Just ask my Chem 2 class about skeletal structures for really, really small stuff like methane or ethane, and they'll tell you they can actually get more confusing for small stuff. They'll probably still say it's confusing for big stuff too, but there's not much I can do about that. All right, molecular Lewis structures. Molecular Lewis structure is an adapted dot diagram or an adapted Lewis structure, but it shows all of the atoms in an entire molecule, where they actually are, so that we can better determine how it's going to bond. The first step in one of these is to draw out the Lewis structures for the individual atoms. Now, there is a set of rules here that I'm going to be going through, and I'm going to try and highlight them some, that you really, really need to keep in mind. The first several examples we do today are going to be so simple you probably won't need to do any of this. But practice it. Practice the rules with the simple ones so that when you get to the complicated ones, you're familiar with how to use them. Okay, and I'm probably going to say that, or I'm not going to say that again. I am just going to say it here and kind of roll with it. You'll either pay attention or you won't figure out what you're doing. So I am going to scroll down so that the rules are at the top of the screen. Oh, I know we lost one. Okay. There we go. Okay. So I am going to do these 4 examples on the board. Now, first thing I should say is that these are supposed to be subscripts. So CH2, O2, Cl2, and N2. Anytime you see an underscore and then a number, it's supposed to be a subscript. And that's the same on worksheet 4. Now, You might notice that there are two boxes under each formula. The first box is for your molecular Lewis structure. I want you to take a picture of it and upload that picture into this box so that you can see it. And then in the next video, we're going to do structural formulas. We're going to use the same examples. I want you to draw the structural formula, take a picture of that, and upload it into the box as well. That way you can see them side by side, and it will be helpful for you in the future. Now, the first rule is make a list of all the Lewis structures. Okay, all of them. So we have H2. That means there are 2 hydrogens. So in a scrap paper, which I'm going to be using this empty space up here, we're going to make a list of both hydrogens. So we need 2 hydrogens. Each one has only 1 dot. We know that because it's in the first group on the periodic table. Still got my diatomics highlighted on this one, but it'll still work. So because hydrogen is in group 1, it has 1 valence electron. Everything in group 2 gets 2, though that doesn't really matter for this. Okay, what you need to keep in mind is that hydrogen gets 1, everything in group 17 gets 7, 16 gets 6, 15 gets 5, and 14 gets 4. You're not going to really be doing dot diagrams for anything that's not one of those groups. So, again, hydrogen is in group 1, so it gets 1. Then anything in group 17 gets 7, 16 gets 6, 15 gets 5, and 14, which is just carbon, gets 4. So hydrogen gets 1 valence electron each. Now, how many total unbonded electrons are there? Well, there are 2. There's 1 in this hydrogen and 1 in this hydrogen. How many bonds can be formed? Well, it takes 2 electrons to form a bond, so half of this number is going to be the answer for this question. So there's only going to be 1 bond in this molecule. Now, oh wait, I put those on the wrong lines. This is 2, this is 1. Now, step 4 does not apply to these because they are too simple. As I scroll down, this will become more important. But the more bonds a molecule or an atom, the more bonds an atom can make, the more centrally it's going to be located within a molecule. So carbon atoms can make 4 bonds. They're going to tend to be in the middle of a molecule. Hydrogen atoms can only make 1 bond. They're going to be on the outside. Okay? So, our hydrogen atoms are going to make 1 bond. Now, theoretically, we could just do this to show our bonds. But this is not the neatest way to do it. It would be much more appropriate to move those electrons to the center so that they're closer together and then circle them. So this is the correct way to draw that Lewis structure. Chlorine is very much the same, except that chlorine has 7 valence electrons. So we go through the same process. Cl, Cl, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, there are 14 electrons between the 2 of these, but only the unpaired matter for what we are doing. So, unpaired or unbonded electrons, there are still only 2, which means we still only need 1 bond. It has to be between this electron and this electron. Now, once again, you could do this. You will not get points for doing that because that is crap. That is messy. Don't do this. Rearrange your lone pairs so that you can put your bond pairs close to each other. All we have to do is swap this individual electron with this lone pair. And this becomes much, much simpler to show the bonds. don't forget to include all of the other electrons in this as well. Now, I have had a couple of people, inevitably, who try to start circling their lone pairs. Do not circle the lone pairs. You will not get full points. You only circle bond pairs. Now, I want you guys to make an attempt at O2 on your own. So pause this, take a crack at this one, then unpause it once you've got an answer, and I will walk you through how to get the answer. So pause it and do it before I draw it out, or you're not going to get as much practice out of this. So go ahead. All right. Now, I'm assuming that you actually did that and you've got an answer. So let's walk through this one. So oxygen gets 6 valence electrons because there are 6, or it's in group 16. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I did that one in a weird order. Now, this time, there are not 2 unbonded electrons. There are 4, because there's 2 in each element. So we are going to need 2 bonds instead of just 1, because we cannot have any unpaired electrons left when we're done. Well, the obvious solution is to do this, right? No, you do not do that. Okay, you cannot form a bond. A bond pair cannot be between a brother and a sister. Okay, we're not doing that. Okay, they have to be from a different atom, from a different element. Not necessarily a different element, but definitely a different atom. So, this one can pair here. I missed. There we go. And this one can pair here, but we need to clean it up for our diagram. So, when we clean this up, we can put 1 bond pair in the middle and another one on the bottom. Now, this is acceptable here because we have to. We can't put it anywhere else. And then we need to add back in our lone pairs. Okay, now that you've seen this one, pause it and do nitrogen. Nitrogen gas should be easy with now that you've done this. So N2, do that one real quick. All right. N2, we have 2 nitrogens. Each one gets 5. There we go. 5 valence electrons. Now, based on oxygen, you shouldn't be too terribly surprised. This is going to be another example of a multi-bond. So nitrogen is going to have 1 lone pair and 3 single electrons. So we set them up like this, and that allows them to form their bonds. This is a little messy. There. So that would be your dot diagram, your molecular Lewis structure for N2. Now, there are 2 more in the notes that I'm going to scroll down and give you. I'm not going to walk through them quite so slowly, but I want you to work on them. Pause this because I'm about to change things up. If there's anything else you want to work on, do that now because I'm pausing it and I'm going to rearrange some stuff. All right, so first we'll do the simple one, CH4. For that, we first need to do a dot diagram for each one of these. So we have 1 carbon and 4 hydrogens. Carbon gets 4 dots, and each hydrogen is going to get 1 dot. Now, as you get better at this, you'll just start to remember how many dots. But for now, I strongly recommend you actually sketch these out. Let me make sure these are actually on the screen. They're a little dark. I'm going to turn the lights on. Yeah, that's easier to see. All right. I don't like to keep the lights on because it increases the glare on the screen, but for this, when I'm using the margins, I feel like I kind of need to. All right. Now, remember what I said. Carbon is going to have to be in the middle because it's going to make more bonds. Now, I frequently see people do this. They go, oh, the hydrogens can each make one bond, so I can do that. There, all my hydrogens are bonded. You can't do this. For one, because it doesn't leave anything to bond with the carbon. Two, because of this other thing that I haven't mentioned yet, because it hasn't really been applicable. All atoms must be connected. Okay? They might be on different ends of the same molecule, but they have to be connected by bonds. Okay, now I'll show you exactly what I mean by that here in a second. But suffice it to say, this won't work. You cannot just have a bunch of hydrogens bonded to each other on the outside because you have a bunch of bonds and you didn't have anywhere to put the hydrogens. Okay, so remember, first off, carbon is going to go in the middle. So let's put carbon in the middle of our structure. Now, how many bonds does carbon need to make? Well, it needs to make 4. Well, how convenient that we have 4 hydrogens that can only make a single bond. So we put a hydrogen on each side of the carbon, each with 1 electron, and it will form this structure. Now, notice the hydrogen is not physically connected to any of the other hydrogens, but all 5 atoms are actually attached. Right? So that is how you do methane. That's the first one. The last one is C2H6. Now, I'm going to give you a tip for this one before I cut you loose to do it on your own. Hydrogen can only make 1 bond. Carbon can make 4. So the first thing you should do is attach your hydrogen. Good Lord, I can't believe I just said that. Attach your carbons with a single bond and then see what you can do around that. Okay? So pause this, take a crack at this one, and then unpause it to see how to get the answer. All right. So I said first, carbons are going to go in the middle, just like they did here. So we have 2 carbons, each one with 4 electrons. And the first thing you should do is connect the carbons at one site. Notice this leaves 6 hydrogens, 1 for each of your 6 bonding sites. Ta-da! Hopefully this should be obvious. We now add a hydrogen at each spot, and this is why I told you to do it on scratch paper, because there's just really not enough room here. We circle these bonds, and that is our structure. Now, I'm going to caveat this real quick. What if instead of CH6, it was C2H6, it was C2H4, and we could only have 4 hydrogens? Well, in that case, you'd have to make sure your hydrogens are on the outside, and you would need a multi-bond. You'd put a double bond between the carbons in order to fill your bonding rules. Okay? Now, there is a homework assignment to go with this lecture, and that is worksheet 4, which is in your notes, in classwork. You should draw out a structure for each of these. Now, this is what my chemistry classes did on Friday. I'm going to do one of these as an example, and then the rest are homework. Okay, and if you need help, you can set up a video conference time, or we could try and do this by email. I don't think this is going to work well by email, but we can give it a shot. The one I want to do with you is I want to do this one. So first off, we need to make a list of these. So we have 4 atoms, 2 nitrogens, 2 oxygens. So we have a nitrogen, nitrogen, oxygen, oxygen. 5 electrons around the nitrogen, around each nitrogen, and 6 around each oxygen. Remember, you have to put one on each side before you can start pairing them up. Now, notice, or remember the first thing I said, the more bonds it has, the more centrally it's going to be located. There's two ways to answer this. Okay, actually, there's like 3 different answers for this one, and I'm going to draw all 3 of them. So I'm actually going to pause this real quick and open a different screen so that I've got a big blank sheet of paper to work with. All right. So the first thing here is, remember, nitrogen can make more bonds, so it should be more centrally located. So we put our nitrogens in the middle, and we're going to go ahead and do the first bond, which has to be connecting the 2 nitrogens. Now, we still need more bonds, so we're going to add the rest of our electrons in, and you always want to put your lone pairs to the outside when you can. Now, notice that there's 2 bonding sites on top and 2 bonding sites on bottom, and each oxygen needs to make 2 bonds. So, we can put oxygen down here, with a lone pair on the top and the bottom, and our singles on the outside. Ditto up here, and we can do our bonds like this. And that will give us one answer. Another option, when you're dealing with nitrogens and oxygens, and when you're not working with carbon and hydrogen, another good choice or another good option is to set them up in a ring. So, for example, for these, if we put nitrogen, nitrogen, oxygen, oxygen, then we could go, instead of doing this, we can go, well, we need bond here, we could do a bond here, and one here. That's going to hit our oxygens, so they're done. We can add our lone pairs here. We can put a bond here. We still have lone pair and a single electron in each spot. Well, we could connect these 2, but we need to move them first. Okay, this is where you should be using a pencil on this. If we erase one of these and move our lone pair to the outside, then we can put a double bond here. So these 2 structures have the same chemical formula, they're just put together slightly differently. So rings are going to be your best option when you can't do the straight chain that you can do with the carbon and hydrogen compounds. Okay, that is where I'm going to end this video. Work on worksheet 4. Send me an email if you get stuck, if you're having trouble, and I will get back to you as soon as I can, especially for those of you who are stuck at home. So, have a wonderful night, and I will see y'all next time.